1, 2, 3.
Yeah, I made it. I was alive.
That's what I labeled it. 1, 1, 1, 2, 3.
Oh yeah, I know.
Are we supposed to do like V1?
In fact, I think I know exactly what happened. I was sitting outside,
did it.
and just sitting in a chair that I hadn't washed in like a couple months. It has the fabric padding,
Like I said,
probably
30
somebody
minutes
in
ago.
there.
I was
I
gonna
sit
phone it
down,
eventually.
scared,
Just
they bite me.
no,
I go to the hospital.
No, I do care though. I was gonna get to it eventually.
Were you here last time?
Terrible fever.
Are you shifting
Because
one
I
too?
peaked out at 102.
I'm not in my seat.
And then not only that, but the antibiotic that
I
they
don't, I
gave
didn't
me
even notice it.
made my face
You'll get
break
to
out.
Greg if you show up.
It would have been better if I just didn't even take the antibiotic. So,
No, I wasn't happy before. I'm not happy.
yeah.
You better be happy. Be happy, get happy.
I feel okay. They gave me some steroids.
Yeah, I get to present my
Feel
computer science 1 semester project.
Figure out what kind of spider.
Hey.
No, they took some blood screening
Yeah.
of me.
I mean,
They
I've
said
got
that I
that
definitely was
intelligent one.
poisoned
I think it's
at like a medium level.
yeah, if you've got
You say you're crazy.
4 points, that is
They
your
got
ship.
Or whatever it was, they
Picks
got.
this one.
It wasn't like the.
It'll then
like
shoot
the
at this one and
terrible
hit, and then shoot at this one and hit, and then if it's already shot here, it'll go, oh, I
It
got
got
shot there, so it'll go.
Did you cross the
shoot back
mafia?
here.
Wow, that's cool.
What's up?
Yep, poison, did you cross the mafia?
Did I cross them all?
This
No, did you cross the mafia? Because you got
Oh, no.
Relatively easy.
Spider bite.
Oh, yeah.
And I keep forgetting to email it to you.
It's horrific.
Is your fever better?
Yeah. That's what, I got bit last week by a spider,
Oh, okay.
and as a result, I've got fever and all
Now
kinds
you're
of terrible
Spider-Man.
stuff. No.
You woke up and you were super strong.
No.
Hands
That's a
sticking in your
secret.
pillow.
Yeah, whatever bit me.
You kill every spider you see now, so it doesn't bite you?
Nah, it's happened once in my life, you know, I'm not too upset about it.
Don't be spider racist.
Yeah. Well,
Oh, okay, so 6.2.
I was telling Paul, I think that what happened was I just sat down on
Yeah,
the
but that
bushes
makes-
that I hadn't sat down on for
That
a few
makes more
months.
sense, okay.
And then there was probably some spiders or bugs in there. And then,
That's only 5.
yeah, I got a couple. Is this good with blank paper?
Yeah.
Okay.
You just said six.
Do you by
Right.
chance have your assignment with the?
In your mind, it's.
I'm at home right now. I'm at home right now.
Why, give it just 2 seconds.
I leave my brain at home.
Can you give me a picture of it?
Program.
Yeah, well,
Okay.
sure.
I mean, I had,
I forgot my notebook,
That's
that's
okay.
plain paper.
right,
So,
it's obvious you did it, and
yeah.
it's okay, don't sweat.
I'll resend it, yeah.
Thanks, I just literally just can't read it.
Okay, so just like, alright.
Yeah, you didn't do it now. Sir, thanks.
Someone demonic.
Sounds
I
good.
know, I'm not.
Oh, gotcha, that's good. I'll skip it. We were good.
Oh, yeah, you do it.
You want me to like send it in sections, so like it's bigger?
Whatever you can do just to increase the visibility,
Alright, yeah.
it's fine. I gave it a try, and
Alright, I understand.
if it was just like you submitted, I'm good reading it. Thanks.
Yep. That is my question. See, now I'm not happy with
Yeah.
that.
Thank you, sir. That's good.
You're inconsistent. This is honest.
I know.
Should take off the whole page. I did that, so that you wouldn't be happy. And I did that, so you I did that for I filled it in for myself.
Right. How do you draw a final pen?
I'm not doing it. I have a 94.
I keep forgetting, you're just not gonna do it.
I think I'm gonna like,
You don't have to do it?
no, because I have an A in the class.
Is that what she said?
Yeah, so, I mean, I might just,
Java?
Java 2.
The first, no, they call it Java first. No, or not, the
No.
first one you need for computer science. Programming.
Oh, programming. No, I skipped the first one.
I didn't take the first, I don't even need to.
No, it's a waste of time and money. It's a
I
waste
didn't
of time
take
again.
it, but I'm taking it next semester.
Alright, we talk. It's good, it's easy class,
Sort of like, if you have a real nice and do it.
but the way she grades it too, I mean, she's computer science, so she likes to be lazy when she can. She talks about it, it's real funny. So what she does is, she grades up until you have an A. So if you have an 89, she's gonna grade as many points as she needs until you hit a 90, and then she'll stop.
Yeah,
So she doesn't actually grade your full assignment, unless you're like at an 80.
I have to figure out if,
You're probably close.
I probably am
The
close.
program that we wrote last class, it calculates your grade for you. So we put in our actual scores. And we wrote a program to tell like the grade average of the class. So we actually put in our homework assignments, and then it came out the
yeah.
average of the class.
That's smart, I could just do that.
Yeah, so she knows. You literally wrote the program. You're probably close, but either way, I just do like the short answer.
I didn't do one.
When you went to get that pencil box, did you look
What
with
we
the
have,
idea of, let me
the
get a pencil
200.
box that looks like I could have
The
made it?
200 point, how much did you get on
Possible.
that? Oh, you didn't know. So that's 300 points.
No, that's 100 points off.
Well, it's
Okay guys,
worth
so
it.
what I wanted to do today was I wanted to talk about the final examination, kind of give you guys a lowdown as to what's on there, and then if you guys have some questions for me, I'd be happy to answer whatever I can. Alright, the other thing I wanted to do was if you had some questions about assignment 12, I'll answer those. Let me start off with that there's one question, 3C, that asks for all the subgraphs of complete 1, 2. Don't even worry about that question. We didn't cover subgraphs, so I'm not going to hold you guys responsible. But a subgraph is essentially basically like a subset. So it's any set of vertices and edges that correspond to a graph. All right, so you guys wouldn't need it for this class. So, and if you ever need it, you guys would see it in the future.
One more thing, on
It's
5B,
fine. Yeah.
do you have to do the numbering for the edge?
Yeah, if you guys would make your own numberings for, if you handed it in already, that's fine, because I can still trace it that way, but it'd be nice for me to be able to have the edges in there, too.
Oh,
Okay.
I didn't put the edges in.
Yeah, so just label them and put them in there,
Okay.
no big deal. Okay, sir?
I have a question about the homework in general.
Yeah.
Whenever we're creating our vertices, and should we be labeling every one of them? Or
Yes,
just- okay.
please. Because that way, like, otherwise it's not defined, and I don't know, like, if you're referencing something, I don't necessarily know what you're referencing.
Well, like,
Maybe it's just.
for
Oh,
example,
are you
like
s- if it's-
3B,
I see what you
for
mean.
example.
If it
so-
says to make a graph, that's okay.
Like, can I just put the vertices and I
That's
connect all the points?
Yes, sir.
but-
Okay. Unless you're referencing some component of that, then you don't have to do that.
Okay.
All right, so I see what you're saying. But if I'm asking you to do like a walk or a loop or
Oh,
something,
yeah, then
some
that's,
circuit,
yeah,
then most certainly doing that.
Okay.
Okay?
got it.
All right. Other questions about the assignment before I talk about the final exam? Okay. And of course, guys, if you do have some more questions, make sure you ask me so that way I can help you guys out with it. Okay? All right. So the way that I drafted the final was that 20% of it was the logic and circuits and things like that. 30% of it was the proofs. Another 20 or 30% was the sets, and then the binomial theorem and the permutations, and then the last 20% was the stuff that we've done most recently. So let me just break it down into, I guess, the percentages, so that like each major topic. And essentially what I did was I just looked at the learning objectives for the course, and I pulled questions based on that. Okay, so I guess if you were to think of, I guess in sections, we could say section number 1, that would be logic, tables, circuits, and syntax. Okay. So let me just go through like some of the most specific things. I'm not going to ask you guys to know everything for the examination. Okay, it's a long semester and I couldn't expect you guys to know everything. But I'll narrow it down to maybe 4 or 5 questions that you guys should know for the examination. Okay, so I'm definitely going to ask you guys to be able to verify something using a truth table. Okay, so or something with a truth table. So verify with a truth table. Okay, and we were able to verify a number of things using a truth table. Okay, so let me just remind you guys of some of the things that we did. We had we had those Boolean equivalencies. Okay, so make sure you guys can determine if 2 statements are equal. So two statements are equal to one another. And remember, two statements are equal if they have the exact same truth table. Okay. If I give you an argument form, make sure that you guys know how to make sure that an argument form is valid. So, and by the way, when I say an argument form, let me just make sure you guys understand what I'm talking about. Okay. If I was to ask you guys, I don't know if there's one on here. Yeah, for example, if you guys look at like 4A, all right, argument form is just going to be a sequence of arguments and then followed by a conclusion. Okay? And maybe you guys might or might not remember, but if I was to ask you guys to be able to determine if this is valid or invalid using a truth table, okay, does anybody remember what the process is for that? Just to make sure, because it's not just making the truth table itself.
Yeah, you make a column for every variable, and then you just work your way out the logic.
Okay. So yeah, we definitely want to make a truth table for everything that's on here. And then specifically, once we have the truth table, we have to look for something specific in that table. So
if it's false, don't you cross it out across?
Correct. If any of these premises are going to be false, you just cross it out, because that doesn't really mean anything to us. What are we looking for with one of these? We're looking for...
At the end, they all have to be true.
Correct. Anything that's completely true. Nice, Marvin. If it's a critical row, okay, so you guys remember the term critical row, okay? What you guys want to do with an argument form is you want to make sure you identify the critical rows, okay? And you're absolutely right, sir. At the end of the problem, the conclusion must be true in all the critical rows, okay? So conclusion must be true. So make sure if I give you guys a truth table that you got with an argument form, you guys are able to do that. Okay. I might give you guys like a circuit, and I might ask you guys to be able to produce the input-output table. Okay, so make sure that you guys can do that. That's certainly still like a truth table. So make sure you have your input-output tables. Okay. Trying to think what else. And when I say that, make sure that you guys can construct a circuit from an input-output table. Make sure that you guys can develop an input-output table. Make sure that you guys can also go to a Boolean statement from that. Okay. So let's just say input-output table to a circuit to an expression. Okay. So if I give you an input-output table or ask you to create one of those, make sure you can do that. So those are the things I would ask you guys to do using a truth table, okay? Hopefully none of those are too difficult. As I seem to remember, most of you guys did very well with the truth table stuff on the first examination, but it never hurts to go back just to make sure, okay? If I give you guys a Boolean expression, make sure you guys can simplify it using the Boolean algebra to verify that the Boolean equivalency is true, okay? So make sure you guys can use the Boolean algebra. To verify an equivalency. Okay. And also, guys, make sure you have that sheet with all the rules of Boolean algebra on it. Okay? If you guys don't have one, you guys can print one offline. Okay? I know it's been a couple months since we've used that. Okay? Or if you can't find it online, you can email me. Okay? Although you guys should be able to do that. But if not, it's fine. Okay, so make sure you have your table for that. Okay, I'll bring a few extra copies, but once I run out, then you're on your own. Okay. All right. Stuff that I won't put on there. Remember we did like that 8-bit addition where I asked you guys to add the two numbers. I won't put that on there. Okay. We talked about multiple quantifiers and Venn diagrams. You guys don't have to worry about that stuff. Okay. Also, like, I don't think there's any questions where I ask you to directly make syntax for anything. So, like I say, write the sentence syntactically or something like that, okay? So basically, I know that the course objectives to me said to be able to work with truth tables, to be able to work with equivalencies, so that, and then be able to work with circuits. So that's what I put on there, okay? Stuff I didn't put like the conversion between the number bases, okay? So what I'll probably ask is I'll ask you guys to do 2 of these 4 types of questions on there. Okay, so if you guys look at, I guess, at the exam review, okay, you guys can cross out questions like, and this is just to make it easy for you guys. You can cross out 7, you can cross out 8, you can cross out 9 because I didn't ask you guys to be able to write anything like that. Let me go up a little bit higher, just to make sure. The rest of it looks like it's fair game. Okay, so on the exam review, if you want to get rid of 7, 8, and 9, if you want to get rid of 10 and 11, bless you, that might be good too. Okay, so again, 7 through 11, you guys can get rid of that stuff. Okay. All right, like I said, I'm assuming most of you guys will get a lot of credit for this, although that doesn't mean don't go home and practice it or look over your stuff. Okay, so everyone okay with what to expect in section 1? Okay, at the end, if you guys want me to work any problems related to that, just let me know. Okay. Section 2 is probably going to be your least favorite. Okay. That's the one with all the proof. So, I'll make it really easy for you guys. I'm going to give you guys 3 proofs. One of them's direct, one of them's indirect, one of them's by induction. Okay? So, just to remind me about the different direct types of proofs, okay? I'll ask you guys to be, I guess, knowledgeable in 4 of the direct types of proofs, okay? Involving integers. So make sure you guys go back, you do your integer stuff. Okay, and integers meaning like even, odd, perfect squares. Okay, so even, odd, perfect square. We talked about being able to do proofs with rational numbers. Most of the time that's just common denominator. We talked about divisibility. And then, I think we talked about division into cases. Oh no, we talked about floor and ceiling and division into cases. All right, don't worry about either of those. Okay, so just stick with those 3, and I think you guys should be okay with everything. Okay, division into cases is just long, quite honestly, and I know it's a time sort of thing. And then floor and ceiling was probably the one that we did the least with. I'm not going to make you guys do that. Okay? All right. For indirect proof, there's only 2 types of indirect proofs, right, guys? The 2 types of indirect proof, just to remind you guys, was contradiction. Okay. And then contraposition. I won't tell you which of the 2 you have to use, okay? So, let me rephrase that. I most likely won't tell you which one of the 2 you have to use. So, what I would do, guys, is I would start by trying contraposition, because it's the easier of the 2, and then if it doesn't work, then go to contradiction, okay? Because it's really easy to see if something would be easy to prove by contraposition. By contradiction, you actually have to work it out to figure it out for yourself, okay? So, my suggestion is to try this one first, just because it's the easier of the 2, okay? And that's the way I usually do it in real life anyway. And you'll be able to see it very easily if it does work. Okay. Now, if I specifically say prove by contradiction, then make sure you do it that way. Okay? All right, and then the only other question that you guys have to remember is the induction. Everybody's favorite. If you guys remember, there were 3 types of questions we worked with mathematical inductions. Okay, so inductions, remember we worked with the series or the sums. Okay. I think we did some divisibility problems. Okay, so make sure you guys go back through your divisibility stuff. And then finally, we talked about inequalities. So I'm going to give you guys one of each from each of those sets. Okay, so make sure you guys go back through, try to practice those types of problems. Okay, and by the way, after I outline everything, if you guys have some specific problems you want me to look at, that's fine. Okay, so if you guys are looking at the exam review, okay, like I said, you guys can cross out something like 12. Okay, so get rid of that guy because I'm not going to ask you guys to do division into cases. Okay, I wouldn't be that cruel. All right. I won't ask you guys to do something as nasty as 13C. That one's just not nice. Okay. The rest of those are fair game. Okay, so make sure you guys are okay with that. Okay. I would look back at the assignments in the exam. Okay, just to make sure that that's the caliber questions that you guys are okay with. These are just additional practice problems if you guys feel like you need more. Okay. All right. The next big section was what we just took the examination on, okay? So that would be section 3. That's like your sets, your counting methods, and your sets, counting methods, binomial. So, sets, counting, and binomial. Here. So, I will not put the procedural definition. So for example, if you guys are looking at your exam review, something like number 15 where it says using only the procedural definition, where you have to use like the Boolean logic in tandem with that, okay? I won't put that on there, okay? So if you guys want to, you can cross that out. If you want to practice it, you're more than welcome to, okay? But I think it would be fair for me to ask you guys to be able to prove something using set laws. Okay, so proof, using set laws. And once again, guys, just like with the Boolean algebra stuff, make sure you have that sheet that has a list of all the Boolean or all the set laws on it. Okay, so make sure you have that sheet. Okay. If you need a copy of it, either go on Blackboard or email me. Okay. I might give you guys a set or a couple sets in a universe, and I might ask you guys to do some operations on that set, like intersection, set difference, and all that stuff. So set operations. And let me put in parentheses what I mean by that, like A intersect B, B minus A, universe minus B intersect A, something like that, okay? Make sure you guys go back through the examination. And I neglected to post the solutions, so I'll make sure I post those for you guys. But go back through those. If you didn't do too well in the exam, or go back through, I think it's assignment 8. That's where you guys can see those to kind of get a little bit of review for that stuff, okay? Most of you guys did really well with that on the examination, okay? But some of you guys did mess up a few of those, okay? I won't put like the isn't element of on there until it's like the subset of the set or something like that. That won't be on there. With the counting methods, you guys know what to expect with those. Okay, so with the counting methods, we talked about like being able to write the number of words or the arrangements that you get out of a specific other word. So like number of words from something like Mississippi. Okay. Or something like the number of words from like stapler or something like that. I'll get out of your way in a second, I'm sorry. I could give you guys like the jury problem, where I give you guys like a jury of 5 is to be constructed from of like 7 men, 8 women, or something like that. So make sure you guys go back through that. So I'll put this in here. Like the jury problem. Okay. And make sure you guys know like the counting methods as well as the probability stuff. Okay, so like I guess number of ways as well as probability. I can't really think of anything else for counting methods that you guys would need. Okay, so like for instance, I think anything up there would be fair game that's on the exam review. So if I'm looking at like 17 or 18, I think both of those are fair game. Okay. By the way, if you guys have a question like during the examination about like what a set really means, like I actually had a number of people on the third exam that didn't answer the question about hexadecimal because they didn't remember what hex was. Just come up and ask me. Okay. I mean that's something that I'd be happy to explain to remind you guys. All right. I don't want you guys losing like 3, 4, 5 points just because you can't remember the set that's involved. That's not my intention. Okay. All right. The only other stuff I guess in section 3 would be the binomial theorem stuff. So make sure you guys go back through that. Okay. Well, actually a couple of things. So, oh, we also had like the proofs of combination and permutation. So make sure you guys go back. You can do a proof of a combination or a proof of a permutation. Some of you guys got really hurt on those problems. Okay, so like for instance, okay, number 19, okay, I think those will be very reflexive of what to expect to see on the examination. Okay, go back through, and of course, guys, if you need some help with those, let me know so I can help you guys out with that. Okay. All right, and then the only other thing we had was the binomial theorem. Okay. I think there were 3 questions from this one, so. So with the binomial theorem, make sure that you guys can expand. So like if I ask you to expand something like 2a minus 3b to the 4th, okay? Or if I ask you guys to be able to write something in closed form, okay? So like, write something like series k equals 0 to n of n combination k of 2 to the 2k minus 2n in the closed form. Make sure you guys do that. Okay. So I'll give you guys a moment to copy all that stuff down. Oh, I'll tell you guys when I'm done writing it out. So, everyone okay with what to expect? This section I think is going to have a lot of like little questions in it. So, and when I say a little question, it's like it won't take you guys as long as like one of these will, but it might have like 3 or 4 of them in there. Okay, so it might like each of the parts might be like 2.5 or 2 points each. So, very similar to what was on the examination. Okay, the only other section that's left is on the last 2 assignments, the new stuff. Okay, so that stuff hopefully isn't too bad for you all. The only thing that might give you guys some trouble is writing the general or the closed form for the recursive sequences, which we can certainly go over if you want to. Okay, so section 4. Okay, that's where you guys have your recursion and your graph theory. So recursion and graph theory. For the recursion stuff, something I might ask you guys to do is I might give you guys a sequence and you tell me the non-recursive form of that sequence. So it might be an arithmetic, it might be a geometric sequence. Okay? So I might ask you guys to write something like 3, -1, -5, -9 in the general form. And when we say general, that would be non-recursive. Or I might ask you guys to write something like, same thing, except geometric. So write something like 2,000, 1,500, 250, 125 in the same thing. Okay, non-recursive form. So hopefully those are pretty easy for you guys, okay? Also guys, make sure that you give me an initial value for these, okay? A lot of you guys on the assignment, you gave me the correct sequence, but you didn't tell me where n starts, okay? And I said it multiple times, it's just as important, if not more important, that you tell me where the sequence actually starts, okay? Otherwise it doesn't mean anything, okay? So you have to give the initial value. Right, and that's why a lot of you guys ended up with like 19s, 18s, 17s on the last assignment, is because I didn't know where n started. Did n start at like 5,012 or did n start at 0? Okay, you got to tell me where it starts, otherwise it doesn't mean anything. Okay. All right, a question that you guys are definitely going to see is that I give you guys a recursive sequence. You guys tell me the general form or the non-recursive sequence. Okay, so write the general form. Okay. Something, and I'm not saying this is exactly what you guys will see, but something like a sub n equals 3a sub n minus 1 plus 2, or a sub naught is equal to 4. Okay. Or b sub n is equal to something like 1 plus b sub n minus 1, okay, where b sub n minus 1, or b sub 0, or actually we could do that plus, we'll make it more interesting, plus n squared, where b sub naught would be equal to something like 2. So, and that's the last few questions that were on assignment number 11. Okay, so most of you guys did really well with the last 2 of those. It was actually the first 2 where you guys didn't have to use those tables that some of you guys messed up on those. Okay, so make sure you guys go back through those and make sure you're good with that stuff. All right? And then there's going to be some graph theory questions on there. They'll be pretty simplistic. Okay, so like for instance, if I ask you guys for like the degree of a graph, or if I ask you for the edge set of a graph, or if I ask you for the vertex set of a graph, okay, there's literally a question on there that says, like, give me one of those, and I'll give you a graph, so you guys just literally tell me that, okay, I mean, that should be an easy 2 points for everybody.
Any isomorphic mapping?
No, there are not isomorphic mappings on there, okay. I might ask you guys to be able to construct a graph, if possible. Okay, so like for instance, I might ask you guys to construct like K5, or I might ask you guys to construct like K 3, 3, or I might ask you guys to construct a graph with 4 vertices of degree 3, 2, 1, 1, or I might ask you guys to construct a tree with 7 vertices, degrees, something like, and this is just approximate, 1, 2, 2, 2, 2, 3, 3. Okay. All right. There won't be any of the isomorphic mappings on there. No subgraphs, even though we didn't learn in class. But like I said, there was that question that I accidentally put on there. So don't worry about subgraphs. I guess the walks and all that stuff, they're not difficult. But I didn't put. Oh, that's right. Euler circuits and Hamiltonian circuits. Make sure you guys knew that. Okay. So. Give an Euler or Hamiltonian circuit. I'll go back through the exam review and take a look, okay, just to make sure that there's nothing I might have missed. But on the exam review, if you guys are working some of the problems, okay, something like 24, make sure you guys go back through that. 25, 26 is fair, 27 is fair, 27 might be fair. Oh, there's two 26s. I'll just do them both. That goes for the same thing with the exam. If there's two of the same number, make sure you do them both.
Nice technique to make us think it's shorter than it is.
Yeah, isn't it? So kind of sneaky of me, my bad. Although neither of the 26s are too difficult, so.
Number 27 is just like, it's like a line with 5 vertices, right? 6 vertices, right?
Which one?
No, 27? No,
Well, it could be. It's all the non-isomorphic trees, okay? So one of them would be like a line that has 6 vertices.
Then the other one could be like a K, the one with the 3.
Yeah, you could have like one with 3, one with 4, one with degree 5.
Five,
Okay, so
okay.
there's a lot of different of those you can make, okay? In fact, for that one, I think there might be something like 8 or 9 different trees you can make for that.
On the exam, we would most likely have a problem that has like 8 or 9 trees or like
No,
the
no,
2
no,
that
no,
we
no.
had in class.
I'll keep it to like, if I do the non-isomorphic ones, I'll keep it to 3, 4, 5, 6. Okay, I'm not gonna
Okay.
make you guys do one that has, I mean, I'm not trying to waste your time with problems that are time consuming, okay? It's basically like, do you know it or don't know it at this point, okay? All right, so that should keep you guys entertained for a couple hours, all right? Anything that I didn't write on the board, don't worry about. I promise it won't be on there. All right, so before I take any questions from you guys, let me remind you of like what you can use. Oh, by the way, for this question right here, make sure you have the sheet for this. So, for the final, you're going to need those 3 worksheets. Okay, so. So let's talk about the references you guys will probably need for the final. Okay. So there were those 3 help sheets that I asked you guys to have. Yep, those 3 right there. Okay. So your 3 help sheets, or your 3, I guess, rules sheets. And just to remind you what those are, that's the one with the Boolean algebra. Okay, so Boolean. We had the one with the sets, and then the one with the closed forms of sums. Okay. So if you don't have those 3, make sure you go on Blackboard and print them out. Okay, so you don't want to lose like 4, 5, 6 points just because you can't do those sorts of things. Okay, those are the easy ones. Okay, obviously calculator, blank paper, pencil, and then I think I told you guys if you want to, you can use the 3 index cards from your first exams. Okay, and then you can introduce a new index card of 3 by 5, or if you don't have those, just take a half a sheet of paper. And you can just rip it in half and just use both sides if you forgot what everything was, okay? If you lost your note cards, okay? I don't care which way you guys do it, okay? Because quite honestly, the time you guys spent for those original note cards was probably a lot more time than you guys would making up another one of those sheets. So, 2 options for, I guess, the note cards. You can use, the 3 note cards from exams 1, 2, and 3, plus 1 more 3 by 5 note card. Okay. Or, like I said, if for some reason you lost those note cards, okay, what you could do is just rip an 8.5 by 11 sheet of paper in half and just use both sides of that.
So that's, if we're going to use the first 3 note cards, it has to be the 3 original ones?
The 3 original ones, yep.
Okay.
That's why I always ask you guys to bring them up so I can staple it to everything. So if you lost it, that's your business. That's not mine, sorry. All right, so another option, and I'm going to put up here, or, okay, so you'll get to use both, sorry. Or you can use 1/2 sheet of 8.5 by 11 paper.
You said both sides.
Hold on, let me check just to make sure. I don't want to give preference to one or the other, although it really doesn't matter.
So since we are using OR, so you can use both of them, right?
No, sir. Or does not mean both. I actually just said that. I said you do not get to use both. Sorry about that. Yeah, it would actually be one side, sorry. Because if you basically, the area is almost the same, so. Sorry, I meant to measure it out. So 1/2 sheet of 8.5 by 11, one side. Okay. All right, so you can use that for reference if you guys want to. Okay, so one or the other, not both. I'll post this on Blackboard to remind you guys. So, everybody clear about references? Any questions, Lucas?
Sorry, I thought we could use both sides of the note cards.
You can, yes, that's correct. So it would probably be better just to use the note cards. But since I streamlined like all the information, so there's going to be stuff that you wouldn't want to put on the note card or on the, I guess, the sheet. So I think that's fair. Okay. All right. So any other questions about the references that I can answer for you guys about anything? Okay. What about any specific problems that you guys thought might be problems for you guys if you were looking at what we have up here? What looks like it might be difficult / impossible /
Can you do number 27?
Can I? I
Yeah.
can.
Let's look it up. The
Do you want me to
possibility.
do it on the board?
If you can. If there's
I can.
Okay, thank you.
Doesn't mean I will.
May you?
I may. I think what you're saying is please do number 27. Right.
Yeah.
I can do that. Absolutely. I'm just messing with you. Yeah, this is actually a really sneaky one because it looks like it's pretty innocent and it's not all that nice. So number 27 up here says list all the non-isomorphic trees with 6 vertices. Okay, so one of them, obviously, the easiest one, would be this guy right here. Okay, so that's a tree, it has 6 vertices, it's not isomorphic. Okay, so if the problem's worth 5 points, I at least give you 1 point because you can draw a line. Okay? Another non-isomorphic graph would look like this. Okay. So that would be another non-isomorphic graph for that. Okay. Another non-isomorphic graph that looks very similar but is not isomorphic to that would be this. Okay, so I want you to notice that these two graphs are not isomorphic to one another. Okay? They look very similar, but they are not. Okay? By the way, this graph would be isomorphic to this graph. So these two graphs would be exactly the same thing, okay? I don't want you guys thinking that all I'm doing is I'm just moving the one that's jettisoning down each time. Because notice that all you'd have to do is just spin this thing around 180 degrees and it would actually be isomorphic to that, okay? So does that make sense, guys, as to why these two graphs are not isomorphic, but these two would be isomorphic, okay? The difference is that this guy, you'd have to do at least 2 traversals from an end to be able to get to that one that's jettisoning in the middle. Okay? So, this, and the way I usually do it is I look at the maximum degree. Okay? So the maximum degree of either of these graphs is 3 of any vertex. Now I want to look at maximum degree 4. Okay? So I could do this. So 1, 2, 3, 4. So that's a graph that would be non-isomorphic to the other ones that I've constructed. Okay. Another one would be basically like the big old plus sign. That would be non-isomorphic if I were to do that. Okay. So in other words, this animal right here. Actually, you know what? I think that would be isomorphic if I did that.
Yeah.
Yeah, it would be. All right. So we can just do the cluster. Right. And I think that would be all of the non-isomorphic graphs that have, of all the non-isomorphic trees with 6 vertices in it. Okay?
That one is 5 vertices.
Right. This one, if you swung it around, it would still look the same. Okay,
No,
so,
but the plus sign is 5, right? 1, 2, 3, 4.
right, and then I'd have to stick something else on there. So I couldn't
Okay.
do the plus sign for that one. Okay. All right. So does that make sense, Art, for that? Okay. Yeah, it's like one of those things where you just draw it out and you just do your trial and error, quite honestly, and you just look to see if like you rearranged it, if it will look the same. Okay. All right. So were there any other specific questions, either on the exam review or anything else that you guys might have seen somewhere that might be difficult for you to answer or anything like that? It might be one of those things where now that you guys know what to expect, you might have to go back home and review stuff at this point, just because, you know, you might not even know like which questions you have until you're working through it. I don't know. So, if you guys can find something, let me know. So, John?
Yeah, in proving like by induction divisibility, I guess the one in particular, for all n is an element of z, n is greater or equal to 0, 7 divides in parentheses 9 to the n power minus 2 to the n.
Oh, yeah. Everyone loved this one. Okay. John, is it okay if I just go through the inductive part of that, since where you put in the k plus 1?
Yeah.
Okay. Because I'm assuming most people would be able to do the basis step, right? Like if you plugged in 0, you could do that, and then you could assume it true for the k plus 1. Okay, yeah. A lot of students didn't like this one too much, so let me go ahead and show you what to do with this. So, this you would go through, you would do all the easy stuff. Somewhere up here, you would say that 7p is equal to 9 to the k minus 2 to the k. Okay, so you have to say that somewhere up top. That's really the only thing you really need to bring down to make those work. Okay, so you go back, you do your inductive step, you do your basis step, and you do your inductive hypothesis. Now you plug in k plus 1, okay, for n, bless you. So let n equal k plus 1. Okay. There's actually a number of ways that you can do this. Some of you guys were really slick on the homework at the exam with this. Okay. So you would get that 9 to the n minus 2 to the n equals 9 to the k plus 1 minus 2 to the k plus 1. Okay. All right. Now this is where you guys had to go through and you had to use a little bit of algebra magic and exponent rules. Okay, so let me remind you guys of the technique for this, or maybe somebody can remind me of this. So, does anybody remember the trick at this point?
Yes, 7 and 2.
Specifically what, Art?
For the 9, you can do split it into 7k plus 1 plus 2k plus 1, like that, right?
Oh, I see what you mean. Unfortunately not. That's not an algebra rule that you can use. You're close. You're on the right track. You're going to break it up into 7 and 2. But
You just make it 7 plus 2 times 9 to the k.
okay, so, Art, before you do that, write it like this. 9 times 9 to the k.
Oh, yeah.
Minus 2 times 2 to the k. Okay? Remember that exponent rule, guys? We can just pull off one of the 9s and put it in front, pull off one of the 1s and put it up front.
Yeah.
Now you can use that trick,
7, yeah.
where instead of 9, you write that as 7 plus 2. Instead of 2, you guys could either leave it as 2 or you could write it as 1 plus 1. Okay? And I'll show you guys why we might want to do that in a moment. Okay? So this would be equal to, instead of 9, 7 plus 2, 9 to the k, minus 1 plus 1, 2 to the k. Actually, you know what? We don't even need to do this. I'm going to try to do this the most expedient way. We can leave this one, that's good. I'm just going to leave this like this, just to make it a little bit faster for us. Okay. So, is that okay with everybody, guys? I didn't just like some exponent and then breaking it up. Okay. Now what we're going to do is we're going to distribute the 9 to the k, and then we can go ahead, we can almost do the induction from there. Okay, so let me go over here and do this. Okay, we're about 2 or 3 steps from finishing this one off. So we're going to distribute that 9 to the k. So be careful with this. Okay, some of you guys made some algebra errors, and you wrote it as like 7 times 9 was 63. It's going to be 7 times 9 to the k plus 2 times 9 to the k minus 2 times 2 to the k. Okay, so that's just distribution. Okay, so everybody see that, guys? Any questions? Okay. Now what you guys will notice is that we almost have like a 9 to the k minus 2 to the k. Okay? So we have a 9 to the k minus 2 to the k. The only thing that's bothering us is that there's a factor of 2 in there, right? So couldn't we just factor out the 2, and then we can use the inductive hypothesis. Okay, so I'm going to factor out a 2. I'm going to be left with 9 to the k minus 2 to the k. And right there inside of that, you get 2 times 7p by this inductive hypothesis. Okay, so remember, guys, a couple steps back, you have to define that something like this would be equal to 7 times a number by definition of divisibility. Okay, so make sure you guys go back through. I think it's the worksheet that we did as well as the exam, because I think there was a question similar to that on there. Okay, so this will be equal to 7 times 9 to the k plus 2. This becomes 7p. That's the induction step. All right. And guys, what you'll notice now is that both of those terms have a factor of 7 in it, right? Because remember, we're trying to show that it's divisible by 7. Let's pull out the 7. That's 7 quantity 9k plus 2p, which is equal to 7 m z. That's actually a really good question. That's a tough one to be able to work with. Okay, so make sure you guys are all okay with those algebra steps, because I don't want to finish working this until you guys are telling me that the algebra looks okay with this. So anything up there that looks suspect algebraically, or anybody need any explanation of the algebra rules? Okay. John, does that make sense? Did I lose you anywhere when you were looking at those? Once we get a look at it.
So you can put 7p in, replace.
Yeah, because what we did, John, was that right here. Remember, with induction, you have to assume that this is true for all n equals k. So right here, we did that induction. So where we said, like somewhere back here, when we do the inductive hypothesis. So remember, you have to assume it true for all n equals k, and by definition of divisibility, if 9k minus 2 to the k is divisible by 7, then 7p equals that by your definition of divisibility. Okay, so this is just like where you say for all n equals k, it's true. Okay, so that's like in the step before that where you have to do all that stuff. Okay, so does that make sense, John? Where that 7p comes from?
Yeah, because ahead of time you already know that 7, like if 7's on the left and the right is 7p, and then
You got it. That's exactly right. Yeah, you know that if it's divisible by 7, you can just, or if it's 15 or whatever it is, you can write whatever. Okay?
yeah.
Okay. All right, any other questions about that one? Yeah, that's a pretty tough one. I'm glad you asked me about that one. Okay. What other specific questions might you guys have about anything that you guys might need to know about what's on the exam, etc., or any specific problems you guys might want me to work? Christian, and then
On the exam review, number 4,
yeah.
specifically the second one.
Oh, the second number 4.
Well, both of them, but mainly the second one.
Oh, I got you. This animal right here.
Yeah.
Oh boy. Yeah, you really want to make me work. Thanks. That's okay. Yeah, this was one that using those rules of logical inference. So this is number 4B. Chris, do you mind if I do number 4B first, since that's the harder one, and then I can do letter A? All right. So for 4B, unfortunately, I'm going to have to copy this down. Sorry, guys. So just give me a second. So this is S or V, and then we have not or, and then we have not P and V implies T. By the way, this T is not tautology. That t is just variable t, not p or q. Implies not s. P implies r. And then therefore t. All right. To be able to do this one, okay, I didn't necessarily say how to do this one, but because you have a whole bunch of variables in there, okay, my suggestion would be that you would use the rules of inference for this. Okay, so let me bring these back up just to remind you guys, okay? So if you have more than 3 different types of variables, my suggestion would be start with the rules of inference. Because if you have 4 variables, okay, doesn't that mean you're going to have 16 rows? And what if you have 5 variables? That would mean you'd have 32 rows. And you guys don't want to deal with that, okay? It's much, much easier to start using the rules of inference. Okay. You may or may not remember, guys, but I think I told you to start with the easiest possible premise and then see what links up with that. So to me, it looks like not R is going to be the place to start with, right, guys? Because it's the easiest thing we have, okay? The only thing that has an R in it is P implies R, okay? So to me, it looks like that we're going to be able to build some sort of statement or one of these basic rules of inference using what we have up here, okay? So does somebody think they might be able to build a statement that can help us with a conclusion? Right, so.
Modest tolerance?
So you would say, for step 1, P implies R. We already have not R, and by modus tollens, that would be not P, right guys? So take a look at your modus tollens, the second of these rules. You have one statement implies another. You don't have the other, that implies that you don't have the first of those. Okay? So the way that you might justify this is given, given, and then modus tollens. Okay? So that's your step 1. Remember guys, once you use them, okay, you can get rid of them. Okay? Doesn't mean you have to get rid of them, but you can. All right. So now that we have a new variable to work with, we have not P. Okay. I'm looking at what we have left. Okay. So we either have statement 1, statement 3, or statement 4, and the only one that really has not P is either statement 3 or 4. Okay. So which of those 2 can we realistically work with? Statement 3 or statement 4?
Statement 4.
It's actually going to be statement 4. Because remember, you can't assume an and. You can assume an or, but you can't assume an and. I think if you guys were to use generalization, okay, if you look at this guy right here, if you have a statement, then you have a statement or anything else you want. Okay, so here's what I might say. I might say that we have not P from step 1. Therefore, we have not P or anything else in the world that we want. Okay, we get a pink elephant, we get a bottle of 151, but for our purposes, what would be the most effective thing to have?
V.
Q.
Q, sorry, Q.
Because we have to have not P or Q.
Q.
Okay, so it could be anything at once. Okay, so this is by generalization. Now that we have that, then we can just go ahead and just say that we can get to not S from there. Okay? And we're pretty close to getting done with this. So let me just go ahead and finish that off. That's the only tricky part of the problem. So is that okay so far, Chris? Okay. Next thing we're going to do, we have not P or Q. We have not P or Q implies not S. So not P or Q. That's from step 2. Given to us, oh, I'm sorry. I dyslexiated that. So this is going to be not P or Q implies not S. We have not P or Q from step 2. This is given. So therefore,
Modus ponens, not
yep,
S.
by modus ponens, we have not S. Good. Okay. We can cross this off. I'm not the smartest guy in the world, but it doesn't look like statement number 3 has any S's in it, but it looks like statement 1 has an S in it, so let's use statement 1. Okay. For step 4, we have S or V. We know that we have not S from step 3. This guy's given. So what can we say as a result? We have to have V, right, by elimination, okay? So look at your elimination. Elimination says that you have one or the other. You know that you don't have one, so you have to have the other of those. Okay? So therefore, you would have V by elimination. Cross this off. We had not P from step 1, we had V from step 4. We're going to conjoin those together to get to not P and V. Okay, so we have not P from 1, we have not, or we have V from 4, so therefore we have not P and V, and that's going to be from conjunction. And then finally, because we have that, we can get to the T that we need. Okay, so 6, we could say not P or V, or and V, excuse me, implies T. We have not P and V from step 5. Therefore, we have T. And that's by modus ponens again. And this guy's all right, so let me get out of your guys' way. I know you're trying to copy down. All right. Chris, were you just making sure I knew how to do that?
Yes.
Okay, I appreciate that. So, or it could just be lying all semester, one of the two, with some wizardry.
Can we also do this before you actually want us to construct like a truth table for one and this for the other?
Well, John, that's a good question, okay? My suggestion would be that whatever's easier, use that method, because I might not tell you which one to use. If there's 5 variables up here, you don't want to make a truth table, okay? That would be 32 rows. You don't want to deal with that headache. If it's something like the one that I'm going to work, that Mr. Andrews requested that I do, like this guy right here has 3 variables in it, just truth table it. Because quite honestly, you might not be able to use the rules of inference to be able to prove this because there's nothing simple to start with, okay? So that might be another way to think about it. If you can't start with like a single argument, you might have to use the table. Okay. So other questions about that one, guys? Okay, and Chris, you wanted me to work on 4A as well, sir? Okay, just to make sure I can do it. Doesn't hurt my feelings. I appreciate it, thanks. Because you know, teaching the 12 course for 12 years in a row hasn't made me rusty. But you guys have only seen it for 3 months. Okay, so this guy right here, 4A, I would use a truth table on that just because it would be a lot easier to do so. I'm going to quickly generate a truth table. So P, and then we have Q, and then we have R. Okay, just to remind you guys. T, 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 F, 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 F. And then T, T, F, F. T, T, F, F. And then F, T, F, T, F, T, F, T. Okay. Obviously, I didn't line those up too well. Oops. Yeah. Oh, sorry. It's bothering me. Obsessive compulsive disorder. It's probably not going to look any better. Oh well.
At least you think it looks better.
Yeah, as long as I think it looks better, that's all that matters, right? I think, therefore I am. What we're going to do, guys, is we're just going to fill out the first 3 of these, okay? I think Marvin told us earlier, as soon as you get to a false, don't even worry about that row anymore, right, guys? Because remember, that's not a critical row, okay? So for P or Q, it looks like that for P or Q, the first 6 rows are going to be true, but then at the end, since it's false for both of those will be false. So we're just going to cross these out. So this guy doesn't matter, and this guy doesn't matter, but the rest of these are true. Then we have P implies not Q, okay? Somebody remind me, I know it's been a long time, but when is implies false?
When the consequence is false.
When true implies false, right guys? That's what the other one around. That's okay. So remember, implies is false. If true implies false, that's the only time that a conditional statement is going to be false. All right? Now remember, this is P implies not Q. So wouldn't it be true that both P and Q would have to be true for that part to be false, right guys? Because that would be true implies not true, which would be false, okay? So if they're both true, then the output from this would be false. Okay? So P implies not Q. Since they're both true, this is false, and we can cross out the rest. Since they're both true, this is false, we can cross out the rest. And then the rest of these are going to be good, I believe. Okay, true, 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 true. Okay. So now we're only down to half the work necessary because we've gotten rid of a few of those rows. The last one we have is P implies R. Okay. So for P implies R, for row 3, we have true implies true. That's good. Okay. So this row is critical. We have true implies false. So that's false, which means that row number 4 is not critical. And then for the rest of them, I think they're good, because this will be false implies true, false implies false. So those are both true. So out of all of that, it looks like that we had 3 critical rows. Okay, row 3, row 5, and then row 6. All right. We're looking at the conclusion. If you notice, the conclusion is R. So right here, this is all good. Right here, this is all good. And then when we get here, that's no good. We can't have a false conclusion in a critical row. So we wouldn't have known that until we did every single possible step for this problem. So for this one, unfortunately, it's not a valid argument for. Okay, so right here, not valid. Okay, so Christian, does that make sense? So, okay. All right. Guys, any questions about something like number 4?
So you could still prove it not valid by using this, or do you have
No.
to use a truth table?
For that one, you have to use a truth table because Greg, there's nowhere to even start
That's what I
on
was
this
thinking.
one.
I had no
Right.
idea. But,
It'd be really nice if you could, but unfortunately.
and because you can't start it, then you have to move on to this step
Correct.
to determine whether or not it
Yeah.
truly is invalid.
Correct, sir. Okay. All right, Brian, you had a question, I believe?
Yeah, do we have to do the mapping of the graphs, like from the,
Oh, the isomorphic thing, or
what we were doing last class where we had.
not on the final? No,
Okay.
I didn't put the isomorphism on. All right,
I
Greg.
have a question from I believe the last exam.
Yeah.
Uh,
I might have an answer.
It says prove for all n that exist in an integer C, n is greater than or equal to 3, where 2 the permutation of n comma 3 minus 2 n the permutation of n comma 2 equals -4 permutation n comma 2.
Okay, so it was, one more time.
Right,
Two-
for all n exists in Z, n is greater than or equal to 3. Okay, yeah, the 2, p, and then n3. And then minus 2np, n2.
Okay, and that's supposed to be equal to
Negative
negative 4p n comma 2?
Yes.
All right, hopefully. All right.
Yeah.
Yeah, this one's not an easy one either,
And
so,
my biggest issue is finding the correct common denominator.
as were a lot of people that
Yeah.
weren't able to do this one. Okay. So, basically what we're going to do is we're going to start by using the definition of permutation, okay? So this would be 2n fact divided by n minus 3 fact minus 2n n fact divided by n minus 2 fact. Okay, so Greg, is that okay so far, just the setup for that? Okay. It's not a combination, remember guys, it's a permutation. Permutations, all you're going to do is just use the formula n fact divided by n minus r fact. So that looks okay?
Yeah.
All right. Common denominators where most of you guys got messed up if you got this wrong. Okay. So which is the common denominator, guys? Is it going to be n minus 3 fact or n minus 2 fact?
N minus 2.
N minus 2. You always go for the bigger one. And n minus 2 is bigger than n minus 3. Okay. So let's rewrite it using n minus 2 fact. I'm going to copy down 2n fact and 2n n fact. So, does anybody think they might know like how to balance these out or to make them equivalent?
Multiply by n minus 2.
Which one?
The
first
left
one?
one, the left one, yeah.
What about the second one? Do we have to multiply by
No.
anything? No. Okay. Greg, well, I'll let you copy it down and I'll make sure you understand why we do that. Okay. Does everybody see that n minus 3 fact is missing one factor of n minus 2? Okay. So basically, since you have one more factor going from here to here, you just multiply it by whatever's missing. Okay. Does that make sense to everybody, guys?
And then once you distribute the 2n factorial, it really, you see it like immediately after.
Yeah, once you distribute, then it's just combined like terms after that point, yeah. So let's go ahead, we can distribute, okay? So by distributing and putting them all in the numerator, 2n fact, okay? So that we will get 2n n fact minus 4n fact, okay? Minus 2n n fact. Okay, so all we did there was we just distributed the 2n fact to those two. All right, and John, I think you're exactly correct. You can obviously see that those 2n n facts are going to go away.
Minus 4.
Yeah, and the minus 4 you can just factor off to the front, and then the rest of it is just permutation n2. Okay, so this would be your negative 4 permutation n comma 2.
Looked a lot harder than it actually was.
Yeah, it really was. Okay, the original problem. Okay. And that's equals. So yeah, I tried to make the one on the exam, and this was the one on the exam, right, Greg?
Yes.
Okay. Yeah, I tried to make it fairly easy for you guys on the exam. Okay, so you didn't have to do like any weird stuff with it. But some of you guys didn't like that.
How should the final answer be set up as?
Oh, like this, just like this, because it's just verified. It's basically an algebraic proof, Greg.
Okay.
So all you have to do is just use your algebra, and this is exactly the very definition, like from here to here. That's the very definition of n minus 2 permutation n2.
Okay.
Okay.
See, because I knew where I needed to be, but I just didn't do the correct process.
Okay. Close enough, right?
Yeah, I wish, but no,
Yeah.
unfortunately.
Yeah.
Yeah.
Okay. So does that help though, sir? Do you see like where you might have made
Yeah,
an error?
no, yeah, I get it. I can
Okay.
understand the problem.
Good. Okay. All right. What other questions look like they might be difficult? I think we have time for one more if you guys wanted to. Okay. So just a reminder, on Wednesday, here's what I'm going to do. Okay. If you guys want to come in and get some help from me, like if you guys have some specific questions, I'll be in the room, regular class time, just come in with some specific questions that you'd like me to work. If you would use that time better to individual study, that's fine with me. I don't care how you want to use that time, that's for you, and I'm going to be in here available for you to get some help, okay? So if you want to call it like a resuscitation session, you can. But on Wednesday, you can get some individual help, at least with math, no therapy. You don't want my therapy anyway, okay? But like I said, if you think that you know everything that there is to know, and you don't need any help from me, that's fine. But what I would expect is if you come in, that you either have some questions for me ready, or you've worked through some stuff. I'm not going to go back through and talk about what's going to be on the exam again, because that's what I just did for about an hour. So, John?
Can I stop by, just turn my assignment?
Oh, yeah,
I'll be
yeah,
here
yeah.
anyway.
Don't forget, that's a good question, okay? Also, for assignment 12, okay, because that's due, you can submit that to me in a number of ways, okay? So, John, if you want to, you can stop by my office anytime between now and Wednesday, by class time if you guys would. So you can drop it off at my office. As long as it's a legible email picture or document, okay, you guys can email it to me, okay? But I have to be able to read it, please, okay? So make sure that you guys can read it, and you can make sure that I can read it. You can just drop it off in class if you want to. There's a number of ways you guys can get it to me. I would just say, like, if you didn't want to come to class on Wednesday, then just email it to me sometime, okay, by class time. Okay, so it's time at 12, by class time. Okay, and I'll post the I do owe you guys some solutions to post. I don't know why I haven't posted them yet, but I apologize. So make sure you guys have that stuff, okay? So, any questions, guys? Everybody know what to expect, okay?
And then you would say probably the best way to prepare is the reviews or.
Yeah,
previous
go back through
exams.
the review, go back through the old exams, and go through
And
the
even
questions that I've
assignments.
wrote on the board. Yeah,
Okay.
yeah, that might be really helpful.
Kind of a quick clarification. If you, like, you have the word staple, let's just say, it seems by issue that's permutation.
Correct, there's no repetition, that would be a penalty.
Right, all the possible ways this can be written.
You just cancel that T out, pretend it doesn't even exist, and since staple has, or stapler, or whatever it is, 1, 2, 3, 4, 5, 6. So that'd be 6, take out 1, it'll be 5 permutation problem.
Okay, so would you rewrite that and all the different?
No, I wouldn't ask you to write them all out, I would, because that would just take too long. I would ask how many there are. Okay. All right, other questions, guys? Okay, John?
Will we have to find like the coefficient of
No.
the term, okay.
Okay, other questions, guys? All right, and don't forget that for the final, just a reminder, because some people might not remember, but the final's when, guys? Wednesday
Up next week.
of December
Maybe 14.
14th, and again, no, 3:15 till 5:15, okay? If you need longer than 5:15, I have no problem as long as there's not another class in here. If there is another class in here, we'll just move it and find somewhere else. Once it hits like 8 o'clock, then I'm gonna start getting pissed, because you've gone past happy hour. And by the way, I will bring in the instructor evaluations during the final examination for you guys to fill out.
Are you getting the homework?
Yep, I have the homework, so let me give that back to you guys, okay? All right, so let me give that back, and then once you get that, then if you have any questions, then I'll just sit there and